Hi friends, this is Bhuvan, and after a short break, I am here with Class 8 Max. So the Class 8 Max, the chapter 1 is rational numbers. So from the previous classes, we have been learning with number system with various types of number system, such as natural numbers, whole numbers, integers. We had natural numbers, whole numbers, and integers. We had learned about three types of number systems from the previous classes. So natural numbers, as we know, from 1 to up to any number, 1, 2, 3, up to infinity. And whole numbers, 0, 1, 2, up to infinity. And integers is a combination of positive numbers and negative numbers along with 0. Like -2, -1, 0, 1, and 2. And it extends on both sides. These are the three types of number systems which I have learned in previous classes. So there are many other types of number systems. So such as real number system, rational number system, and unreal number system. So we are going to learn all these in the next upcoming classes. And in our eighth class, we learn about rational number system. So first, we have to know detailedly about the natural numbers, whole numbers, and integers. So natural numbers is represented by the letter n, and we know 1, 2, 3 up to infinity. And the difference between natural number and whole number is this 0. If the 0 is present, it is a whole number. If 0 is absent, it is a natural number. That is the only difference between natural number and whole number. And what is integers? Integers is simple. Positive numbers with negative numbers along with 0. Okay. Positive numbers with negative numbers along with 0 is called integers. Okay. So now we will be having four types of properties in maths. As you all know, closure property, commutative property, associative property, distributive property. So what is closure property? Let us revise. Closure property means if you add two numbers from any number system, we should get the same number in the same number system. For example, if we take natural numbers, if we add 2 plus 4, both belongs to the same number system as natural numbers. And what we'll get as result? We'll get result as 6. And 6 belongs to the same number system as these two belongs. That is a closure property. So when we add two natural numbers, we'll get a natural number. Okay. But when we subtract two natural numbers, we won't get a natural number. So 2 minus 4, what is this? Minus 2. And minus 2 belongs to integers and it's not natural numbers. Okay. And natural numbers is not closure under subtraction. Then 2 into 4, we will get 8. Okay, 2 is a natural number, 4 is a natural number, 8 is a natural number. So it is closure under multiplication. And division, let us take. Simple. 2 by 4. What is this? Simplest ratio, 1 by 2. On coming into division, 2, 1, we'll get 0.5. 0.5 is not a natural number. It's a fraction. As we all know, it's a fraction. So it's not closure under division. This is about natural numbers, closure property. And let us talk about commutative property of natural numbers. Okay. Commutative property of natural numbers. What is commutative property? Means A plus B is equal to B minus A. B plus A, or A minus B should be equal to B minus A, or A into B should be equal to B into A, where A and B are some numbers belonging to any number system. There is no specific rule. So let us take same example. 2 plus 4, 6. But 6 plus 4 plus 2 is also 6. As the result is same. Okay. Commutative property in natural numbers in addition is applicable. But let this subtraction. 4 minus 2 is 2. But 2 minus 4 is minus 2. Which is not same. So it is not applicable. And multiplication. Same. 2 into 4, 4 into 2. Both result is 8 only. So it is applicable. And division, 2 by 4 is 1 by 2. 4 divided by 2 will get 2. 2 and 1 by 2 are not same. So commutative property is also applicable only to addition and multiplication. Okay. So according to the commutative property rule, it is applicable only to addition and multiplication. Next, associative property. So, associative property says that A plus B plus C is equal to A plus B plus C. Okay, this is the associative property. Generally, we'll determine associative property for addition and multiplication only. Because as we know, it won't be applicable for subtraction and division. It is a general rule. A into B into C should be equal to A into C into B. And this is applicable for natural numbers. Okay. So next, distributive property, it comes under multiplication and it's applicable for natural numbers. So if we take whole numbers, we know 0 comma 1 comma 2 up to infinity. Infinity means we don't know what is the proper value of it. So now closure property, let us take closure property. Okay, closure property means if we take two numbers from whole numbers or two subtraction and addition and any operation if we solve, we should get the same number which belongs to the number system of whole number. So let us take the same example. Now let us include 1 plus 9 equal to 10. Okay, 1 minus 9 is equal to minus 8. 1 into 9 is equal to 9. 1 by 9 is equal to 1 by 9 only. So this belongs to whole number, but this does not belong to whole number. This belongs to whole number and 1 by 9 does not belong to whole number. So it is applicable only for addition as well as multiplication. Okay, addition as well as multiplication. So now let us take the commutative property. Let us take the commutative property. So commutative property means similar. So 1 plus 9 is equal to 10 and 9 plus 1 is also equal to 10. Both are equal. 1 into 9 is equal to 9 and 9 into 1 is equal to 9. Okay, both are equal. It is applicable only for addition and multiplication. Okay, and let us go with integers. Integers, as we already know, it is applicable for closure, commutative, associated, distributive properties only for addition and multiplication. And in some cases in subtraction also. And now let us take about rational number. So first let us discuss what is a rational number. Okay. So first, what is a rational number? Let us see. So we know we have seen some examples such as 1. 1 is divided by 2, we will get 1 by 2. And this 1 by 2 does not belong to natural number, does not belong to whole number, does not belong to integer. Then which number system does it belong? So in order to include these numbers, a separate number system has been created, which is rational number system, let us see. And the rational number system, it be having some conditions and a general terms is also there. So this is, so now let us take. So how the rational number should be represented. Okay, as we know integers from minus infinity to plus infinity, rational number is also represented in the form of P by Q. Okay, P by Q. It is represented in the form of P by Q. And what is the condition? Q cannot be equal to 0. Q should not be equal to 0. Division by 0 is not possible. And next, P and Q should belongs to integers. Okay, so it belongs to integers. Okay, and this symbol is belongs to symbol. Okay, and P and Q belongs to integers. Okay, P and Q belongs to integers. This is the main condition of rational numbers. Q should not be equal to 0. P and Q belongs to integers. And now let us see the 4 properties of mathematics in this. So let us start. First, we will see how to do the operations in rational numbers. Then we will discuss the properties. First, let us take addition. Okay, so now let us take addition. Okay, so for doing addition, it is same like as fractions only. As we have dealt with fractions, it is similar to fractions. Okay, as we already know, it is similar to fractions only. Okay, so the rational numbers is also similar to fractions. So simple. How we will deal with fractions? we have to make the denominator equal and then we have to add the numerators respectively. Okay, so now let us take the example as a wish. 3 by 5. First example, 3 by 5, and let us take 7 by 5. Okay, so now if we add these two numbers, 3 by 5 and 7 by 5, and denominator is same. So in the result also, the denominator will be 5. Denominator remains the same. Okay, and the numerators we have to add. 3 should be added with 7. 3 plus 7 is 10. Okay, and 10 by 5, it gives us 2. This is how we should do addition. And let us take the another example. For example, 4 by 3, 3 by 5. Let us take this example. So now if we add, okay, are the denominators same? But first you have to check whether denominators are equal. Here the denominators are not equal. Then what we have to do? We have to equate the denominators. We have to write the equivalent fractions of these. We have to write the equivalent fractions of these. Until that the denominators should be equal. So this is a long process. So how to do? Simply we have to find the LCM of 3 and 5. 3 and 5. We have to find the LCM. So let us write 3 multiples. 3, 3, 6, 9, 12, 15. Next, 5. 5 multiples are 5, 10, 15. What is the least common multiple among these? It is 15 only. So, this is the least common multiple. What is the least common multiple? 15. So, first we have to write one fraction, 4 by 3. How to make the denominator into 15? By which number we have to multiply the numerator and denominator? We can multiply by 5. 3 5s are 15 as we know. 4 5s are also 15. So 20 by 50. Okay, it is the equivalent fraction of 4 by 3. Like this only we have to find the equivalent fractions. And next 3 by 5. We have to get denominator as 15. So into 3 into 3. 9 by 15. So in order to bring the denominators equal, we have to multiply with the respective value so that both the fractions or both the rational numbers denominator should be same. So 20 by 15, 9 by 15. So now we have to do general addition. Normally how we'll proceed if the denominators are equal, the same procedure. 20 by 15 plus 9 by 15. So denominator will be 15. And what is 20 plus 9? 29. Okay, so this is the result. Okay, this is the result. Like this only, we will proceed in adding the. Like this only, we'll proceed in adding rational numbers. Okay, in adding rational numbers. So let us take one more example. Okay, then we'll get a proper clarity. Okay. Okay, let us take one more example. Then we might get a proper clarity. Next. Now the example which we are going to consider is 3 by 7. Okay. Minus 6 by 11. Okay. 5 by, okay, let us take 5 by 22. These are the three common we are going to take. Okay, this is the common we are going to take, and then we will take one more also. Next, what is one more? Minus 8 by 25. Okay, so if they give like this, 4 numbers or 4 rational numbers if they provide, how to do addition respectively. So now take the denominators 11, 22, 21. And we know 7 thrice will give us 21. And 11 twice will give us 22. So first, let us add these two and let us add these two next. Simultaneously, let us add. So now, first, what is the first step? We have to add 3 by 7 plus minus 8 by 21. Okay, so what is the LCM of 7 and 21? 7, 7, 14, 21, and so on. 21 table will give us first itself 21. So you have to find the LCM as 21 and 3 by 7 into 3 into 3 plus minus 8 into 1 because we don't need to change the denominator. So 9 by 21 minus 8 by 21. It gives us 1 by 21. Okay, 1 by 21. So let us keep it aside and let us do the next procedure. What is the next procedure which we have to solve? We have to solve is these two we have to add. Okay, so minus 6 by 11, 5 by 22, and 11 multiples are 11, 22, 33, 44, and so on. 22 multiples are 22, 44, and least common multiple is 22. So in order to bring the denominator into 22, we have to multiply by 2. And here is already we have 22. So no need to multiply anything. Minus 12 plus 5 by 22. This we can write it as minus 7 by 22. So plus minus 7 by 22. And next we'll follow this procedure. Now next normal, general. So 1 by 21 minus, okay, plus minus 7 by 22. Okay. So now here, these both, find the LCM. LCM of 21 and 22. They are consecutive numbers. And we know consecutive numbers are always mostly co-primes. So their LCM will be product. Product of these. Product of these is the LCM of consecutive numbers. So find the product of 22 and 21. We will get 462. Okay, so to make this denominator into 22, we have to multiply it by 22. Okay, here 21. Simple logic. So 22 by 462 plus minus 147 by 462. This gives us 125 by 462. Okay, like this we have to proceed with the addition if there more than 2 is given. We have to find an easy process to add all these numbers. Subtraction is the same. What is the meaning of subtraction? Addition of a negative number. So 1 by 2, let us take 1 by 3. Subtract these two numbers. 1 by 2 minus 1 by 3. What is the LCM of 2 and 3? 2 is, consecutive numbers. They are consecutive numbers. They are consecutive numbers. What is the LCM? 2 into 3. 6. We know it. But to prove it, let us check. 2, 2, 4, 6, 8, and so on. 3 is 3, 6, 9, and so on. See, the least common multiple is 6. So in order to avoid this process, we will remember certain tricks. So this is one of the tricks. So to bring the denominator into 6, we have to multiply it by 3. Okay. So 3 by 6 minus 2 by 6. Which will give 3 minus 2 by 6. Okay, this is 1 by 6. Okay. 1 by 6. This is the result. Okay, so next, let us do the multiplication. But in multiplication, no need to equate the denominators. We don't need to make the denominators equal. Same example, 2 by 3 into some 1 by 3. Let us take. Okay, no need to equal the denominators. If the denominators are equal, leave it. If the denominators are not equal, then also no need to equate the denominators. Same, multiply the numerators, multiply the denominators. So what is 2 into 1? 2. What is 3 into 3? 9. This is the result. So other example, let us take 8 by 60 into 9 by 12. Okay, let us take. So here we have to multiply the numerators, multiply the denominators. Okay, in case if these two are multiples or we can cancel each other. So 8 times, we can calculate 8 times 1, 8 times 2. Okay, and these both are a common multiple of 3. So 3 times 3, 3 times 4. Okay, and simplest form. So 1 by 2 into 3 by 4. This is result is 3 by 8. Or you can multiply and make it into simplest form. For example, what is 8 into 9? 72. And what is 16 into 12? Let us calculate. 192 by 192. Okay, so now let us make it into the simplest form. Make it into the simplest form. It the both the values are divisible by 8. So 8 nines are 8, 24 times. Again 3 table. 3 times 3, 3 times 8. So again we are getting the same result. Any procedure according to your convenience you can follow. So next, division. Division is simple. So division is when they give 3 divided by 8, we can write it as 3 by 8. 3 by 8. If they give 3 by 8 divided by 4 by 6. Okay, if they give like this. First, write it in the normal form which we used to write. 3 by 8 by 4 by 6. Okay, 3 by 8 by 4 by 6. So now how to proceed it? 3 by 8. This we have to convert it into multiplication. So 1 divided by, let's take another example, 6 divided by 3. Okay, 6 divided by 3 is equal to 6 into 1 by 3. Am I correct? 6 divided by 3 is 2. 6 into 1 by 3 is also 2. So we can reciprocate. So this one we can reciprocate and we can multiply into 6 by 4. Okay. So now 2 table. 2 tries, 2 4 times. Now 9 by 60. This is the answer. Okay. And this is the way how we have to do operations like addition, subtraction, multiplication, and division in rational numbers. And two more concepts are there, like how operator 1, operator 0 is getting applicable. Okay, operator 1 is if we multiply any rational number with 1, we will get the same rational number. Its value does not changes. If we add 2 by 3 plus 0, we will get the 2 by 3. The value does not change. This is multiplicative identity. Means if you multiply any number, rational number, real number, natural number by 1, you will get the same value, which value does not change. Okay, and if we add any number with 0, we'll get the same number. So this is known as multiplicative identity. This is known as additive identity. So in this way, we have to do operations with this operations in rational numbers. So now let us recap what we have learned in this class. We have introduced the number system. We have introduced the number systems like first rational number, natural number, whole number, integers. And we have seen the 4 properties, how they are applicable to various number systems. Okay, and as we normally know how to do operations in integers, natural numbers, and whole numbers. So now today's class we have learned how to do operations in rational numbers like addition, subtraction, multiplication, division. Okay, so you can practice a lot of sums, and any doubts you can post it in the chat box so that I can reply. Thank you. Please like, share, subscribe.